Nice. So we're back for our module about ray tracing, where we're going to learn how to use path tracing, okay? Once you enabled ray tracing in project settings, rendering, we enabled the path tracing, okay? That is basically a render offline as Corona or V-Ray. So let's, for example, here, inside here, the scene that actually we can compare. Look, camera 01. Oh, I think I'm gonna hide the window. Let's see only the scene. All right, immersive mode. Nice. Immersive mode, 30 FPS. I think it's okay. We're not losing a lot of frame. It's okay. In 100, let's see. Let's put 120. Let's see if it's possible. All right. Nice. We have a flickering here happening, but it's okay for now. Photoshop. I'm gonna open the Photoshop so that we can compare and see the improvement of the quality by using path tracing. Control V. Print. Okay, the type of lining is looming that we're using. Makes sense, right? And ray tracing for the reflections. Actually, for the translucence. Looming plus ray tracing. Okay. Translucence. All right, nice. Once you enabled ray tracing, we have access to the path tracing. That is a render offline. I go in lit, path tracing, and I click here. Look, it starts rendering literally, okay, of our scene. Okay, it's calculating the bouncing, direct light, shadows of direct and indirect light by using ray tracing to do it. Okay, obviously there are some limitations. You can notice these defects here, okay, and it is related to limitations or bugs, that starts when you use path tracing with looming. We are using Nanite. That is a technology of Unreal Engine 5 that was made to work better with looming. We are using ray tracing. We are rendering with path tracing. So you have a lot of things happening at the same time. So it can happen this type of incompatible, but look the level of the quality of the rendering, and literally it is being rendered. Let me minimize this screen here. I'm going to disable the nanite, okay, of this object. All right, we did it, and apply changes. All right, we disabled. Now it got back being like perfect, the model, okay? Let's access the post process to configure the parameters, okay, of path tracing. Post process details. I'm gonna bring to the immersive mode. It would be cool if we change it here. Okay, the details, take this here so that we can see in the full screen. Okay, nice. We can see, let's see. I'm gonna minimize this. Let's see, reflections. Translucency, path tracing. In path tracing, I can adjust some things like quality, bouncings, look at this, max bounces. It's the amount of time that the light is being bounced in our scene. For example, it comes here, there, and it is bouncing a lot of times, 32, or only one time, 2 times, 3 times, 4 times, 10 times, 32 times, it's a good value. So the light is bouncing 32 times. the samples per pixels, like the quality of this sample. So it's putting 16,384 samples for this image. So the path tracing, it's going to process, and process, until it gets 16,000, over 16,000 samples. It's a really high quality. But the cost for this is time of rendering. The image is being rendered, okay, literally. We can decrease this time of rendering, okay, by decreasing the amount of samples, okay. So this way, instead of waiting 16,000, over 16,000 samples per pixel, it can emit like 100 pixels, actually samples per pixel. Okay, or 25 samples per pixel, 2 samples per pixel. And obviously, you can notice that the less is this number, the amount of samples, faster is gonna be our render, okay. However, you get a lot of blur, more like the noiser on our image. So let's get back to 500. It's gonna take a longer time to process the rendering, literally, okay. However, I will have a better quality, a higher quality, and Unreal will need to add less denoiser to compensate this less of samples, okay. Let's wait. Okay, it's processing. You can see here the fireflies, look at this. And the FPS, when it finishes, it got like 120. Okay, let's take some prints here. Okay, print. This one, path tracer. Okay. Samples equal 500. Okay, we have this result of image here. We can see kind of a blur here. We are missing some details. So let's render with 2000 samples. 2000 samples, it's okay. I mean, it's way less than 16,000, but 16,000 would take a longer time. But it's more quality than 500 samples, okay? We can do it and we can compare, okay? With path tracing, we can have a lot of ways to deliver a project to the client. For example, if I want to deliver a still image, I can, like a static image, I can use the path tracing, okay? It's fast, and I can make a high resolution screenshot, okay? Or if I want to deliver an animation, I can render by using the move render quill that we saw in the classes of sequence. If I want to take a tour, a virtual tour, I can use Lumen to calculate the light and the reflections and use the ray tracing for the translucence. Okay, this way I get more FPS. Okay, and still I can, things are happening in real time. So you can identify in what moment each technology is better to use, okay? For example, I'm rendering and I want to deliver a screenshot to the client with the most possible quality. Do it by using path tracing, okay? And you can create a render of this by using high resolution screenshot or move render quill, where I can render in 4K, in 8K, in 16K, okay? So let's wait this finishes here, okay? The calculation with 2000 samples, we print and then we compare with 500 samples, okay? It has finished. Let's print this, okay? And Control V. Let's see. Look at this. Before and after, before and after, before and after. Nice. Here, probably it's the effect of the night. Let's disable the night of this curtain. Apply changes. As we have more curtains in the scene, it's gonna do also for the other curtains. Okay, let's see a little more about the parameters of path tracing. Post process, let's see, we removed the window here. Do you remember that? Okay, window details. Okay, it got back. Immersive mode. Path tracing. So we can control the max bounces, samples per pixel. This third parameter here, it's a filter that we apply on the image. It's like a filter of interlacing, you know. Look at this. Filter width for the path tracer, lower values are sharper and more interlaced. Larger values are softer and blurrier. Okay. Let's see. Okay, so 3 is a good value. Emissive materials. If I want or not to give support to emissive materials, okay, by using path tracing. For example, let's create a sphere here. Shapes, sphere. Look, let's put a sphere in the scene. Look at this. Okay, sphere is here. We can reduce the size. Nice. Let's apply an emissive material here to this sphere. Let's see what we have here. It's a material that emits light. Okay, so let's see. We have this one, but I don't think. Let's see. Yeah, this one it has as well. It's an instance. This one. I'm gonna duplicate this. All right, I duplicated this, and let's apply it. Okay. Look. Immersive mode. Let's reduce the quality. The amount of samples, okay, so that we can render faster. 300, immersive mode. Look at this. If I want or not support to emissive materials, okay. If I check this, if I enable this, it's gonna generate GI. If I uncheck this, they're not gonna be supported. Okay, let's finish the render here. Nice. Let's disable this. Okay, look at this. It doesn't emit GI if I disable this. Okay. The max path exposure. Basically, the exposure of our scene with path tracer. Okay, I think we can, yeah, leave it enabled. All right, the reference depth here and the noiser. Okay, that acts or not in the final of the render. If I disable this, when it distributes the 300 samples per pixel, the image isn't gonna be improved, okay, using this noiser. Okay, it's not gonna remove the noise, you know. So it has finished already, 120 fps. However, look the noises in our scene. It's not using the noiser after the calculation is finished. So I would need to increase, for example, here to like 20,000 samples, and then I would wait the samples to be distributed until the image gets better, not using the noiser, you know. If I use the noiser, I can decrease the amount of samples per pixel, because in the final it's gonna compensate these samples by applying a denoiser in my scene. Okay. Obviously, the less the amount of samples, more the noiser it's gonna have to apply, okay, to remove the noise. Okay. The more is the samples, the amount of samples, less the noiser it's gonna have to apply to remove the noise. Okay. So it makes sense to use the noiser, okay, and decrease, for example, the amount of samples per pixels in our scene. Okay. Nice. Let's wait here the render to finish, and then we're gonna finish this class, okay, where we talked about path tracing. Okay. There are ways of rendering by using path tracing with move render queue. Okay. But in this module, I'm gonna only show you how to enable and how to configure, okay, only with ray tracing. Okay. But for example, to render with path tracing, we can make a class how to do it, you know, showing how to do it by using move render queue, you know, to render the image in a really high quality. Okay. But this module, we're gonna learn only about enable and disable. Okay. And after, we can make a module showing how to render using a technology. Okay. Because here we are learning the concepts, and you are going to be the person that is going to identify when to use a resource or another based on your goal. Okay. If you're going to take a virtual tour, it's interesting to use looming for the propagation of the light, looming for the reflections, and ray tracing for the translucency. If you are going to make a video, it makes sense to use the path tracer, for example, with move render queue, okay, to render. If you have a lot of time to render, that makes sense. Okay. I'm going to make a video and I don't have a lot of time to render. So it makes sense to use looming for GI, looming for reflections, translucence for materials, for the translucent materials, and move render queue to render. Okay. We're going to adjust, and we're going to understand how to use one thing and how to use when to use another thing. Okay. I'm gonna finish this class here. We close this module of ray tracing, and in the next module we can make a module of varieties. Okay. And we're gonna learn how to render by using path tracing plus move render queue. Okay. See you.